Hello everyone, myself Dr. Lakshmi Soujanya, working as an associate professor in the Department of Mathematics from Marri Reddy Institute of Technology and Management. In the previous two sessions, we discussed how to find the rank of a matrix using echelon and normal form. Now today we'll discuss about how to find the inverse of a matrix using Gauss-Jordon method. So here to find the inverse of a matrix, we have some formula to find A inverse. If it is a 3 by 3 or 2 by 2, we have some formulas to take A inverse. That is, A inverse is adjoint of A by det A. We have to take adjoint of A as cofactors and we have to calculate det A. Up to 3 by 3, okay, you can find the value by using standard formula. But if your matrix is order more than 3 by 3, we can go with the standard definition. You will get the answer, but it takes very lengthy procedure and more time to complete the solution. So here to reduce the time span, what we will do is Gauss-Jordon define one procedure to find the inverse of matrix using some row operations only. We can go with only row operations. So here the procedure is, together you have to take the matrix A and the identity matrix I. At a time, you have to consider two matrices, the given matrix A of order m by n and the matrix I, identity matrix. Sorry. You have to take a matrix A of order m by m and the identity matrix I. So here to get the A inverse value, what you have to do is, your focus is you have to convert this matrix A to identity matrix. So to convert this matrix A to identity matrix, you have to go with some row or column operations. In normal form, we know how to convert the given matrix to identity matrix. There we applied row and column operations, upper triangular, lower triangular, then we converted identity matrix, isn't it? Now here in Gauss-Jordon method also, you have to convert this matrix A to identity matrix. But here whatever the row operations we are applying, the same row operations you have to apply to the corresponding identity matrix also. That means if your matrix order is 3 by 3, then you have to choose the matrix order of 3 by 3 for identity matrix. Here, whatever the row operations we are applying on these three columns of a row, the same row operations are applicable for the three columns which are existing in the identity matrix also. So when we are changing A, it impacts the I also. But if you are taking column operations, suppose if you want to change second column in A, that doesn't impact on the column in I. Why? Because the column number is varying here. So it doesn't shows any impact on the identity matrix. That's why, because of that reason only, in Gauss-Jordon method, you have to go with only row operations. We can't apply column operations in Gauss-Jordan method to get I. That means by using row operations only, you have to convert the given matrix to upper triangular, lower triangular, then identity matrix. Now, after getting identity matrix here for A, then obviously the corresponding matrix gives the inverse matrix A inverse. So, in Gauss-Jordon method, what we have to do, you have to take the given matrix A with the same order, you have to choose the identity matrix also. Your focus is you have to convert the given matrix A to identity matrix and apply the same row operations to the corresponding identity matrix, then definitely you will get A inverse value. So, this is the procedure for Gauss-Jordon method. Now, see one problem. So, here I am taking one 3 by 3 matrix. Using Gauss-Jordon method, find the inverse of this 3 by 3 matrix. So, what you have to do here, together you have to take matrix A with the identity matrix. So, first write down matrix A. Your matrix A is 1, 1, 3, 1, 3, minus 3, minus 2, minus 4, minus 4. Together with this A, you have to consider identity matrix also. What is the order of this A matrix? 3 by 3. So, choose 3 by 3 identity matrix, that is 1, 0, 0, 0, 1, 0, 0, 0, 1. So, here what we have to do, your aim is you have to convert this matrix A, given A, to identity matrix form I. That means what are the steps we have to follow? Upper triangular, lower triangular, then identity matrix. So, first convert this to upper triangular form. Upper triangular form means you have to change 1, minus 2, 4, minus 4 to 0. So, follow the same procedure column wise in a step. column wise you change the values to 0. So here the first column values are 1 minus 2. First you change 1 minus 2 to 0. That means which rows we have to change here? R2, R3. So the row operations are for R2 and R3. So in R2 I have 1. The non-changing row in this step is R1. By using R1 only we can change R2, R3. So in R1 here I have 1. So by subtracting both the rows clearly it is 0. That means the row operation for R2 is R2 minus R1. Next in R3 here I have minus 2. Here I have 1. So in R1 if you get 2 then minus 2 plus 2 you will get 0. That means the row operation for R3 is R3 plus 2R1. Now what about the value? We are not changing first row. See, now you have to focus on the 6 values, not 3 values. You have to focus on the 6 values which are existing in that row. Okay. So we are not changing first row. Your first row is 1, 1, 3, 1, 0, 0. Include these values also. Next, R2 minus R1. What is R2? R2 is 1, 3, minus 3, 0, 1, 0. Minus R1. R1 is 1, 1, 3, 1, 0, 0. Now subtract both the rows. 1 minus 1 is 0. 3 minus 1 is 2. Minus 3 minus 3 is minus 6. 0 minus 1 is minus 1. 1 minus 0 is 1. 0 minus 0, 0. Next, R3 plus 2R1. First write down R3. R3 is minus 2, minus 4, minus 4, 0, 0, 1. 2R1. Multiply the first row with 2. 2, 2, 6, 2, 0, 0. Now add both the rows. This is 0. Minus 4 plus 2 is minus 2. Minus 4 plus 6. Minus 4 plus 6 is plus 2. 0 plus 2 is 2. 0. 1 plus 0 is 1. So again represent the upper diagonal values, lower diagonal values. These are your lower diagonal values. Now still we have one more value, minus 2 to 0. That means which row we have to change here? We have to change R3. Which row we can use here? The row which is similar to R3 is R2 only. So by using R2 only we can change R3. So here I have minus 2. The corresponding value in R2 is plus 2. By adding both the values clearly you are getting 0. That means row operation for R3 is R3 plus R2. Then this is 1, 1, 3, 1, 0, 0. We are not changing R2 also. R2 is 0, 2, minus 6, minus 1, 1, 0. Now R3 plus R2. R3 plus R2 means 1. 0 plus 0 is 0. Minus 2 plus 2 is 0. 2 minus 6 is minus 4. 2 minus 1 is 1. 0 plus 1 is 1. 1 plus 0 is 1. So here we converted all the lower diagonal matrix values to 0. So upper triangular form is completed. Now you have to focus on lower triangular. Here remember one thing, don't go with column operations. You have to do row operations only. Since we are using row operations in a single step, you have to focus on one column. So in this step, now to convert the matrix to lower triangular, you have to convert all the upper diagonal values to 0. Now column wise only you can change the values. Why? Because we are doing only row operations. We are writing only row operations. So in a single step, you focus on one column values only. So first here I will convert the values which are in the third column to 0. Last column, third column values to 0. That means which rows we have to change here? R1 and R2. Till now we focus on R2, R3. Now to get the lower triangular matrix, we have to focus on starting rows. That means here we have to change R1, R2. So the row operations are for R1, R2. Which row we can use here? Which row we are not changing? The non-changing row is R3. So by using R3 only we can change R1 and R2. So here the corresponding value in R3 is minus 4. Here I have 3. Here I have minus 4. There is no common multiple. So do the cross multiplication. R1 is changed as 4R1 plus 3R3. Similarly for R2, here I have minus 6 and here I have minus 4. There is no common multiple. So do the cross multiplication, that is 4R2 minus 6R3. Now this is equal to, we are changing first row. So first write down row operations for first row. So the row operations for first row as 4R1. Multiply the first row with 4. That is 4 1s are 4. Again 4. 4 3s are 12. 4 0 0. Next 3R3. Multiply the third row with 3. 0 0 minus 12 3 3 3. By adding both the rows you will get 4 4. 12 minus 12 is 0. 4 plus 3 is 7. 0 plus 3 3. 0 plus 3 is 3. Next, how we are changing R2? What is the row operation for R2? 4R2. Now multiply the second row with 4. 0. 4 2s are 8. Minus 24. Minus 4. 4 0. Next 6R3. Now multiply the third row with 6. 0 0. Minus 24. 6 6 6. By subtracting, this is 0. 8 plus 0 is 8. Minus 24, minus of minus 24 is plus 24. So minus 24 plus 24 is 0. Minus 4 minus 6 is minus 10. 4 minus 6 is minus 2. 0 minus 6 is minus 6. Next, we are not changing R3. So write down R3 as it is, that is 0 0 minus 4 1 1 1. Now see, we converted all the values which are in the last third column. So now we have one more value. We have to convert the value which is in the second column. That means here you have to change first row only. So your first row is R1. You have to change R1. Now which row we can use here? The row which is similar to R1 is R2. By using R2 only we can change R1 to 0. So here I have 8, here I have 4. Here if you get 8, 8 minus 8 you will get 0. That means you have to multiply the first row with 2. So the row operation is R2 minus 2R1. So how we are changing first row? So the first row is changed as R2. First write down R2. R2 is 0, 8, 0, minus 10, minus 2, minus 6, 2R1. Multiply the first row with 2. 8, 8, 0, 14, 6, 6. By subtracting both the rows, you will get 0 minus 8 is minus 8, 8 minus 8, 0, 0 minus 0, 0, minus 10 minus 14 is minus 24, minus 2 minus 6 is again minus 8, minus 6 minus 6 is minus 12. Next, we are not changing remaining two rows. Remaining two rows are 0, 8, 0, minus 10, minus 2, minus 6, 0, 0, minus 4, 1, 1, 1. Now see, in matrix A, we converted all the below diagonal values and above diagonal values are to 0. Now you have to convert the matrix to identity matrix. Identity matrix means all the diagonal values are 1. So here, in first row, here I have minus 8, here I have 8, here I have minus 4. So in these three places, if you get 1, then you will get identity matrix. That means you have to divide the first row with minus 8, second row with 8, third row with minus 4. Then what about your matrix? First row with minus 8, that is 0. First row with minus 8 means 1, 0, 0, minus 24 by minus 8, minus 8 by 8, minus 12 by 8. Next second row with 8, so 0, 1, 0, minus 10 by 8, minus 2 by 8, minus 6 by 8. Next third row with minus 4, 0, 0, 1, minus 1 by 4, minus 1 by 4, minus 1 by 4. Now see, here we got identity matrix. So now what is the inverse? This value is your A inverse. That means A inverse equal to minus 24 by 8 means 4 2s are 8 or 8 3s are 4. So this is minus 3. Both are minus signs. So you will get plus 3. Next minus 8 by 8 is plus 1. minus 12 by 8 means 4 2s are 8, 4 3s are 12. So this is minus 3 by 2. We are dividing first row with minus side, so this is minus 10. So this is plus 3 by 2. Next one, minus 10 by 8. Minus 10 by 8 means 4 2s are 8, 4 5s are, sorry, we can divide with 2 only. 2 5s are 10, 2 4s are 8. So this is minus 5 by 4. And this one is minus 1 by 4. And next, minus 6 by 8 means minus 3 by 4. Next one, minus 1 by 4, minus 1 by 4, minus 1 by 4. This is a required A inverse value. So what we have done here to get A inverse, you have to convert. Together you have to take the given matrix with the identity matrix. By using row operations only, you have to convert the given matrix to identity matrix. Then you will get the remaining matrix, corresponding matrix as A inverse. So see another problem on this. Now your next problem is using Gauss-Jordan method, find the inverse of 2, 4, 3, 2, 1, 1, 1, 2, 1. Again together you take matrix A and identity matrix, that is 2, 4, 3, 2, 1, 1, 1, 2, 1. So with this matrix, you have to consider identity matrix also. Since it is of order 3 by 3, I'll take identity matrix of 3 by 3 only, 1, 0, 0, 0, 1, 0, 0, 0, 1. Now what is the first step? You have to convert the given matrix to upper triangular form. Upper triangular form means convert all the lower diagonal values to 0. So focus on column wise. In the first step, I'll focus on first column values, that is 2, 1, 2, 0. Which row we can use here? R1. Which row we have to change? 2, 1 means we have to change R2, R3. So what's the row operation for R2? R2 is R2 minus R1. For R3, here I have 1, here I have 2. So here if you get 2, then 2 minus 2 you will get 0. That means you have to multiply the third row with 2 and subtract from first row. Now what about this? We are not changing first row, that is 2, 4, 3, 1, 0, 0. Next R2 minus R1, that means 2 minus 2, 0. 1 minus 4, minus 3, 1 minus 3, minus 2, 0 minus 1, minus 1, 1 minus 0, 1, 0 minus 0 is 0. Next 2 R3, multiply the third row with 2, that is 2, 4, 2, 0, 0, 2. And next R1, R1 is 2, 4, 3, 1, 0, 0. So by subtracting both the rows, you will get 0. 4 minus 4 is again 0. 2 minus 3 is minus 1. 0 minus 1 is minus 1. 0 minus 0, 0. 2 minus 0 is 2. Now see, we got the upper triangular. We converted all lower triangular matrix to 0. Now you have to convert the matrix to lower triangular. That means all the above diagonal values to 0. So what are your above diagonal values? 4, 3, minus 2 are above diagonal values. So in the next step, you focus on one column. So I will convert the values which are in the third column, 3 minus 2 to 0. That means which rows we are changing here? We are changing R1, R2. Which row we can use? The non-changing row is R3. By using R3 only, you can change R1 and R2. So here I have 3. The corresponding value in R3 is minus 1. Instead of minus 1, here you are getting minus 3. By adding both the rows, you will get 0. That means the row operation for R1 is R1 plus 3 R3. Next for R2, the row operation is, here I have minus 2, here I have minus 1. So in R3, you need to get 2. That means R2 minus 2 R3. Then this is R1, we are changing as R1. R1 is 2, 4, 3, 1, 0, 0. Next 3 R3. Multiply the third row with 3. That is 0, 0, minus 3, minus 3, 0, 6. Now by adding both the rows, you will get 2 plus 0 is 2, 4 plus 0 is 4, 3 minus 3 is 0, 1 minus 3 is minus 2, 0 plus 0 is 0, 0 plus 6 is 6. Next, R2 minus 2 R3. R2 minus 2R3 means what is R2 here? R2 is 0 minus 3 minus 2 minus 1 1 0 2R3. Multiply the third row with 2 now. 0 0 minus 2 minus 2 0 4. So again by subtracting you will get 0 minus 3 minus 0 is minus 3 minus 2 minus of minus 2 plus 2 so that is 0 minus 1 minus of minus 2 plus 2 so that is 1 1 minus 0 1 0 minus 4 is minus 4. Next we are not changing third row, so third row is 0 0 minus 1 minus 1 0 2. So we have one more value, we have to convert 4 to 0 to get lower triangular matrix. So again we have to change R1 first row. How we can change R1? What is the row operation we are using here? You can use here the corresponding value in R2 is minus 3. There is no common multiple between 4 and 3. So do the cross multiplication. Then this is 3R1 plus 4R2. So how we are changing R1? 3R1. First multiply the first row with 3. This is 6, 12, 0, minus 6, 0, 18. 4R2. Now multiply the second row with 4. 0, minus 12, 0, 4, 4, minus 16. So by adding both the rows you will get 6, 12 minus 12, 0, 0 plus 0, 0. And next minus 6 plus 4 is minus 2, 0 plus 4 is 4, 18 minus 16 is again plus 2. Next we are not changing remaining rows, 0, minus 3, 0, 1, 1 minus 4, 0, 0 minus 1, minus 1, 0, 2. So now see, we converted all the below diagonal and above diagonal values to 0. That means we got upper triangular and also lower triangular. Now you have to get an identity matrix. That means all the diagonal values are 1. So what is the next row operation? In R1 I have 6. So you have to divide the total row with 6. That is R1 gives rise to R1 by 6. Next in R2 I have minus 3. So divide the entire row with minus 3. R2 gives rise to R2 by minus 3. Next in R3 I have minus 1. So I multiply the entire row with minus sign. Then this is R3 gives rise to minus R3. Now what about your final matrix? You have to divide the first row with 6. So 1, 0, 0, minus 2 by 6, 4 by 6, 2 by 6. Next R2 is divided by minus 3. Then this is 0, 1, 0, minus 1 by 3, minus 1 by 3, minus 4 by minus 3. Next R3 has to multiply with minus sign. Then this is 0, 0, 1, 1, 0, minus 2. Now see, we got the identity matrix on left side. So the right side matrix is your required A inverse. So what is A inverse? Minus 2 by 6 means minus 1 by 3. 4 by 6 is 2 by 3. 2 by 6 is again 1 by 3. Minus 1 by 3. Minus 1 by 3. Minus 4 by minus 3. So this is plus 4 by 3. And next multiply the third row. Third row is 1, 0, minus 2. So this is the A inverse value. Is it clear how to find A inverse using Gauss-Jordon method? So what we are doing here, you have to convert together. You have to take matrix A with the identity matrix form. Convert the matrix A to identity matrix form in 3 steps, upper, lower and identity matrix form. Then the corresponding right side matrix use your A inverse. So this is a procedure for Gauss-Jordon method to find the inverse of the matrix. In the next session, we'll see how to find the linear system of equations. Thank you.